Hello. Today I'm going to try to derive the formula for the gain of a common emitter amplifier, which is the type of amplifier using a BJT that you're gonna encounter the most. So let's get cracking on this. Okay, so let me draw this. Okay, so let's draw the transistor. So this is of course the base. This is the collector, and this is the emitter, and here you have RC, and here you have a VCC. So power, the plus of the power supply, and same thing on the other side. So you have RE, and let's say you have the ground here. Okay, so let's put down some symbols. So here you're gonna have IC. So this is the DC, current, and you have a AC part, IC. So this is all caps and this is small. Okay. And what do you have here at C, which is actually the output, huh? So that's what we're interested in. At C, at the collector, you have a VC and a small VC. At the emitter, you have a VE and a small VE, and you have IE and a small IE. So this is DC, this is AC, DC, AC, DC, AC, DC, AC, and this is the this is the input. So we also have VB and V small b, DC, AC, and IB. Okay, so this is DC, this is AC. So for that transistor to work, you need to have VB equal V. So this is DC. VB equal VE plus 0.6 or 0.7. So I'm going to put 0.65. So that's forward bias. And you also need to have VC greater than VB. So this is forward bias and this is reverse bias. So this one has to be forward biased and this one has to be reverse biased. If this one is not reverse biased, the current is going to go this way. You want that current to jump. So that's why it has to be reversed. Okay, so let's get started. So what's the gain? And I'm talking about the AC gain. So the gain is basically it's gonna be something that's gonna, the gain is gonna be so again the output is here for the common emitter amplifier at the collector. So it's gonna be, the gain is gonna be VC over VB. This is the input here at B, the base. Okay, so we need to, let's get some formulas down and then we'll figure it out. Okay, so first formula, we're gonna focus on the collector. So we have BCC equals RC times IC DC part plus IC AC part plus BC plus VC. So this is DC, this is DC, this is DC, this is AC, this is AC. So it helps to separate the two. So you have BCC equal RC IC plus BC, so that's DC. So that's the, you know, the when you do the biasing, you only look at the DC. So that's your DC part, and you have an AC part, which is you don't have the, so you just have RC IC plus BC equals 0, and that gives you BC equal minus RC IC. So that's your AC. So let's remember this one. Okay, so that's 1. Okay, so now let's look at the other side, the emitter side. So you have basically VE plus VE. So this is DC, this is AC equals RE IE plus IE. So this is the DC, this is the AC. Again, let's separate the two, one into DC part and AC part. That's going to simplify things. So we have VE equal RE IE, that's the DC, and you have VE equal RE IE, that's the AC part. So that's a good one to remember, this one. Okay. So now we have so this is a C. Huh? Okay, so we still need a few things. So let's continue. Okay, so now let's look at the forward bias. We know that VB plus VB, so that's the voltage at the base, is equal to the voltage at the emitter, VE plus VE plus 0.65 volt. This is DC, this is AC, DC, DC. So if we separate again, we have VB equal VE plus 0.65 volt. This is the DC part, so this is this thing here. Okay, same thing. And the AC part is VB equal VE. AC. So that's very important. So the AC part at B is equal to the AC part at E. Okay, the AC voltage at the emitter is equal to the AC voltage at the base. that's a very important result. So let me move this thing a little bit, because we still have one last thing, and then everything is gonna come together. The last thing we have is that the collector current is equal to the emitter current. So IC plus IC is equal to IE plus IE. So this is the DC, AC, DC, DC, AC. If we split into two parts, IC equal IE, so this is DC, and IC is equal to IE, so that's the AC. Okay, so now let's try to work out that gain, and I'm gonna write here over there so that everything is in. Yeah, I think if I go up here. Okay, so let's try to express VC, which is the output, with respect to VB. So this is our output and this is your input, and that is going to give us the gain. So this is again AC. We're only interested in the AC, of course. So we know that VC equals minus RC IC. That comes from this one. And we know that IC is equal to IE approximately. So minus RC IE. But we know here IE is equal to VE over RE. So let's plug that in. This is a C here. Okay, it's not a E, it's a C. So is equal to minus RC times IE, which is equal to VE over RE. Okay, so let's rewrite that. So VC is equal to minus RC over RE times VE. But okay, so that's the last thing, this one. We know that VB equal VE, so we just plug in VB instead of VE. So equal minus RC over RE times VB. So we have established that VC, so AC, equal minus RC over RE times VB AC. Okay, so the AC voltage at the collector over there, which is our output, remember, this is a common emitter amplifier, so this is the output here. So the output is equal to minus RC over RE times VB, which is the AC voltage at the input here, input at the base. So this guy, that's the gain. Okay, and why do you have a minus here? It's because there's a phase inversion. It's 180 degree out of phase, the input and the output, so that's why you have the minus. So if I draw let's assume that this is the VB, then the VC is going to be out of phase, amplified but out of phase. Okay, so like this, and this is going to be VC. Okay, so that concludes my presentation about how to calculate the voltage gain of a common emitter amplifier. Okay, please like, comment, subscribe, and I'll try to make more. I'll see you around. Bye.